Welcome. This is Coach Dorf. We're in section 5.4, and we're doing a homework example. In this one, we're supposed to evaluate an integral. What makes this problem different is that we have an absolute value symbol inside the integrand, the function that's after the integral sign. So let's see how we could solve this problem. The important part to consider in this problem is, when does the absolute value symbol make a difference? For what values of x? Well, here we have 3x minus 1 as our integrand, the function after the integral. And we're going from -2 to 1. So for what values of x does the absolute value symbol make a difference? Well, that happens when x is a negative number. So what we're going to do is we're going to take our integral from -2 to 1, 3 absolute value of x minus 1 dx, and we're going to break it up into two integrals. We're going to break it up into the first integral that's going to be from -2 to 0 of the same quantity, 3 absolute value of x minus 1 dx, plus the integral from 0 to 1 of 3 absolute value of x minus 1 dx. And earlier in chapter 5, we talked about that we can do this as long as the top number of the first integral, which is 0 in this case, matches the bottom number on the integral of the second one, which is also 0. All right. Why did we pick 0? Because from -2 to 0, that's when the absolute value makes a difference. It changes the sign of x because x is a negative number that we then put into the absolute value. From 0 to 1 on the other integral, it doesn't matter what is the absolute value, doesn't make a difference because my x values are always positive. All right. So this first integral here, then the important part to see here is when I put in a number for x, it's going to be a negative number. And when I take the absolute value of that negative number, I get a positive number back. So whatever negative number I put in for x, I'm going to get the negative of it back. So this is equivalent to saying that my integrand is 3 times -x minus 1. Now, don't make the mistake of thinking -x is a negative number. It's not, all right? What's important is to realize that x is a negative number because it's between -2 and 0. And when I have a negative sign in front of that number, the two negatives cancel each other out, and now x becomes a positive number. And so it's equated to the absolute value of x. You can check this by just picking out a number. Let's say we took x is -1, all right? If x were -1, then 3 times the absolute value of x minus 1 would be 3 times the absolute value of -1 minus 1, which would be 3 times 1 minus 1, which is 2. On the other hand, if I did 3 times the opposite or negative of x minus 1, which is what I'm saying we're going to have here for this part here, we're showing that these two parts are equal, then when I put in the -1 there, I'm going to get -1 minus 1, and I get 3 times 1 minus 1, which I also get 2. So these two parts are equal to each other, all right? For the second integral, I've got from 0 to 1, I've got 3. And now what happens with the absolute value? I want to get rid of it. So how do I get rid of it? Well, in this case, x is between 0 and 1. It's a positive number. I take the absolute value of a positive number, I still get that same number back. So I can just replace this with x, and I get this. All right? Make sure you understand the difference here. In the first integral, from -2 to 0, we put in a negative x to say that that was equal to the absolute value of x because our x value was negative. In the second integral, from 0 to 1, our x is a positive number, so we can replace the absolute value of x with just x. All right, so then what do we have? Well, we then simplify these integrand parts. All right, so we have -3x minus 1 dx for the first integrand, and then the second one from 0 to 1, we have 3x minus 1. And now we can solve this problem just like it's a regular fundamental theorem of calculus problem. All right, so I take the general antiderivative, I take an antiderivative of -3x minus 1, and that would be -3/2 x squared minus x, and I'm evaluating that from -2 to 0. And for the second integral, I'm going to get 3/2 x squared minus x, and that's evaluated from 1 to 0. All right, and so now I just plug in my numbers here. I'm going to get -3/2 0 squared minus 0, and that's for the first part. And then the second part, I'm going to put in -2 We get -2 squared minus -2 there, and that's the first integral. And then the second one, I'm going to put 1 in, so I get 3/2 1 squared minus 1. And then I'm going to put in 0, and I get 3/2 0 squared minus 0. Now I'm just going to simplify this. I'm going to get 0, and then here I'm going to get -2 squared is 4 times -3/2. Then that's going to be a -6. And then I'm going to get a negative minus a -2, which will be +2. And then here I'm going to get 3/2 minus 1 and a 0. And so then -6 plus 2 is -4, and I have a negative sign in front of it, so that's going to be +4. And then this is going to be 1/2, so it's going to be +1/2. So I have all that here, and so this is then going to be 9/2. What does this look geometrically? Well, let's try drawing a graph. I should say for x between -2 and 0, we have our function here, which was -3x minus 1, which again came from the fact that we had 3 absolute value of x minus 1, and replaced the absolute value with a negative x, again because we have a negative value of x, so it makes it positive. So what's the graph of this look like? Well, it is a function, let's see, it looks like this. If I plug in a point at -1, then I'm going to get 2, and at -2, I'm going to get 5, and this makes sense. This has a slope of -3 and a y-intercept of -1. All right, and then if I do the other one for x between 0 and 1, my function was this, again coming from 3 absolute value of x minus 1. All right, so that's going to look like this function here. And so my integral represents the area under the curve, and it makes sense that this area is positive because there's more of the green above the x-axis than below axis, and our 9/2 was positive. Hope that helps.